All right, we're recording. I think you're good to go, Carlos. We're going to mute here so we don't talk over you.
Okay, sounds good. I just need confirmation when I share my screen that is working. Let's see, entire screen. Oh, okay. Am I sharing now?
Yeah, we can see it here.
Okay, so let's get started. This is the first one, so it's okay to start a little bit late and mechanic. So welcome to the first Knative Tech Talk. This should be a short and a very precise technical talk. I'll be covering eventing, and then after me, there will be another talk about serving. And being the first one, we are going to talk about how the introduction. So, and we'll be doing this regularly. So if you missed it live, you can watch it on YouTube. So have some feedback. Somebody can mute. Echo. I have feedback. Okay. So if you want to get to know the Knative project, you can go to our website. It's located on knative.dev. Today I'm going to talk about eventing. If you go to the docs, you can find an introduction on eventing. So there we have build, serving, and eventing. If you go, I think I already have it open. You can go to eventing, and then there's a top component, and then I'll be talking today about the different sources that we have. Let's do a quick slides before we go down into the code. So Knative eventing, it allows you or us to build Knative eventing, event-driven applications. I try to break it down into 4 components that you will need to have for an event-driven application. So you have your emitting component, which could be things like databases, storage, webhooks, streams, things that are emitting events. In Knative, we use the standard of cloud events from cloudevents.io. We use that spec to as the event mechanism. For those events, we have Knative sources, and we'll go deeper a little bit onto that as some examples. Basically, that's the component on the discipline of listening to events, and this could be receiving events or pulling for events. And then those events are composed with different resources like Knative channels and Knative subscriptions. Today, the latest version of Knative is eventing is 0.4, and we have channels and subscriptions. The next version hopefully will be next week, and it will have something, some new resources that we can talk in another tech talk, which are broker and triggers. And all that is to compose applications with those events coming in, and through pipes and composing applications that at the end of the day, they are targeting a compute resource. In this case, we are referring to a Knative service, but it could also any type of compute resource. For example, we support a DNS entry. So if you want to access something through internal DNS or external DNS, you can do that. I think it was me that had the echo. Sorry about that. Where I was. So event-driven applications. The first example is the very simple example to get started with eventing is source to service. Basically, you create a YAML file which defines a Kubernetes resource. It's the kind will be the different type of the sources. In this case, I'm showing the most simple one that we have in the Git repo, which is a cron job or interval. This is an example of running a scheduled job that it would emit an event every minute, but you can change it. And this would sync into a service. In this case, I can sync to a DNS entry. I can sync into a service. So I have here an event process. We also have an event display in the Git repo. So it's very convenient for debugging. So this is going directly from source to service. As you can see, I was not using the compositions things like research channels and subscriptions. If you want to get started, I have a this demo I'm showing is on GitHub. I just uploaded that today, and we can take a look of how that looks like. So if you go to Chrome to service, this is an example. I don't have to create a channel, just going directly from source to service. So let's see if I can deploy this. I'm using a Kubernetes terminal UI. It's a nice UI that gives me some color. So if I do kubectl get sources, I can verify that I don't have any sources. In this case, it's Knative sources. I use K for short for kubectl, and I have my YAML file. So for example, I have this. I'm going to be using the Chrome to service. So this one basically is the schedule and the data I'm going to be sending to that service, which is hello from Knative source to service, and the sync, which is my service, my event process. And I already have some resources, some Knative services already deployed. So I do get service, and I have two there in the repo. I have one that is, I don't know if you guys can see that, but I have one that is like a dump of the message event display. This is one in Go. I created a new one called event process. It's just in Node.js. So let's deploy that. So if I do K, let me clear this. Type. If I do K, apply -F, eventing from service. I will be creating a Kubernetes resource source. So this it's created. I can also do get sources, and I can see it there. If I want to inspect it, like with the -O YAML, and I can also do that and see that is deployed. And then after a minute, it will start emitting events into my function on my service. So it's deployed, ready, sync provided, and it's valid schedule. So now I'm using a tool which I really like for Kubernetes is Stern. So if I run Stern, if I can find Stern, let me see. So if I'm running Stern and I want to inspect the logs for user container and follow those events, I can see here that my event is just dumping the cloud event that is coming in. So it will say every minute will send me a message saying hello from Chrome, job source to service. If you want to have a peek on that JavaScript, it's just a HTTP server with a /post, and the message comes in as a cloud event. In this case, I'm just replying back a new cloud event and dumping like console.log for debugging purposes. So as you can see, you can get the headers. I'm printing the headers and the body. So that's kind of like getting started with the one that I show, the most simple one, source to service. So basically, you're going from a source to a sync, in this case, a service. And if you look at the docs, I think I was showing previously, there's documentation here that shows different type of event sources. We have some for AWS, Heartbeat. We have one for GitHub. We have GCP PubSub. And if you are creating one, go ahead and submit a pull request to update this documentation. Basically, it's in this Knative docs repo, and you can submit a PR and update that table. If I can find it here, I think it's this table. Yeah. So the next example, before we run out of time, if my the other person present, is source to channel, and then that channel you can hook it up to a service and through a subscription. So we'll be using the same example, Knative source. It could be a database change, a file uploaded to some cloud object storage. It goes to a channel, and then somebody will subscribe to events coming into that channel through a resource called subscription. So in here I have the channel. I'll be creating a channel. There's different type of channel provisioner. So in this case, it's in memory, but we also have Kafka, and we have other types of channels which are in the documentation. So in this case, for demo purposes, usually we use the in-memory one. So you will be creating this channel that the events will coming in. Same thing as before, I'll be creating a cron job source, but in this case, the sync is not a service, it's a channel. So it will go to this channel named CJ1, and then I'll create a subscription that subscribes the channel, anything that comes into this channel to this service through a subscriber. So I have the representation here. If you want to, let's go and deploy this. Let me undeploy the other one. So I can do K delete minus F. This is sometimes useful for people to see, because sometimes they're getting started and don't know the mechanics on this type of thing. So if I do get sources, it should be gone. I forgot the YAML. So I'll be doing the cron eventing cron channel. So as you can see, it has the channel in one YAML file. You can have different resources. That's something that I learned. I didn't know before. So you can have a YAML with different YAML pieces. So I'm defining the channel in that YAML file, the cron job, and the subscription. We can see one of those. I think I showed in the slide, so it's not point of showing it again. So that's the deployment. So let's deploy this K. Let me clear this so you can see. Make this a little bit bigger. K apply minus F eventing cron to channel. And in this case, I deploy 3 things: the channel, the cron job source. So the source could be, like I said before, something that is going to a database and checking for changes, or cloud storage receiving webhooks, for example, GitHub, or some PubSub that is sending events, or maybe Kafka. Recently, I think this week, we merged the Kafka event source. So now you can tap into something like a Kafka cluster with the broker information and the authentication, and get Kafka messages streamed into Knative. See that deploy. So I think it should be deploy. Let me see the conditions. Yep. So it's deploy. It should be emitting a message, a cloud event every 1 minute. Let's go to Stern to see. And since I can do subscription, let me double check if I'm doing event display or the other one I'm using. I'm doing gate subscriptions. If I can type, yeah. This guy is a subscription, and I want to see it. Show me the raw, or show me the conditions. So this is the raw information of that, like if I do -o YAML. So it's sending into a event process. So it's the same service. So it should come in. It should be coming in. If I do clear, or just do buffer and run it again, I'll be getting those messages every minute, but this time going into a channel. So if I have a second or third service or function that I want to tap and also receive those events, I can create another subscription for each of those services, so I could have multiple subscriptions in there. And lastly, I want to show another example, which is source to channel, a channel to a service like we had before. But in this case, the service is replying back with a cloud event, and it could be a mutating cloud event or just creating a new cloud event from scratch. For example, it could be an example of a use case or an application. It could be like if you have an application that is dealing with a dealership, right? Cars, and as new cars come, get inserted into the database through the admin. It uploads the picture and the description of the car. That would emit an event from the database. It will go to a channel where it gets processed, and then the channel can the service can reply back with notifications, and then those notifications get queued into a channel for different types of notifications. So one subscription could be subscribing to send to that same message to send an email. Another one could be sending a Slack message. Another one could be sending a push notification or a Twitter DM. So that would be an example of that. And the YAML for that looks like this. Basically, you're composing that in YAML. Hopefully, there will be a high-level abstraction tools that will have visualization and editing tools from that. But in this case, I'm creating, let me show this a little bit larger. So I'm creating a channel A, channel B, as before. In this case, instead of a database, I'm just using the example of the cron job, but I have a subscription that is one subscription to process the event that knows about cars in the database, the change event, and then a meeting looking for who are the people that wants to get messages or notify what a new car or gets inserted with a certain criteria. And then that will produce a notification to channel B. And then we could have a, so it will reply back to the channel B, and then there could be another subscription on channel B listening for cloud events about notifications, and the only job of that service or functions is to send an email, basically. So there's a separation of concerns. One function to process the message, and another function deals with sending emails out. That's just an example. As a real use case, as you can relate to that, creating an event-driven application. So there's no service-to-service HTTP calls. You go through a composition type of queue. For example, Kafka is one popular one. I think that's all I have. I don't know if there's questions or we just move to the next one. I wanted to be very quickly because just cover one small topic on these multiple tech talks I'll be doing. Let me go back to the meeting. People like still watching or behind. There's the folks from Google office. I think there's questions in the Slack. Going to be recorded? Yes, we're being recorded. Please drop here the GitHub repo. Somebody already did. What is the name of the plugin that you're using to interact with kubectl? Oh, this Kui. It's a project that is going to be added to the kubectl 6 CLI from Kubernetes. It's called KUI. Somebody posted the repo. It's under IBM, but it's going to be moved under the Kubernetes SIG to like augment the CLI with and customize and all these nifty things for people that want to have a terminal plus like UI interaction. But it's the same thing as kubectl. I think that's it. Any other questions from the YouTube channel? I can check the YouTube channel. There's that sad faces in here. There's no sound on YouTube Live. I only see the same slide. Nothing. Oh, so sad. We need to fix that. I think I'm done, unless somebody wants to say something else. Or there's a break person.
Oh, no, I was going to present next if no one else had any questions.
Okay. Let me stop presenting.
All right, well, so I'm going to go ahead and talk about Knative serving. I have API here, but really it kind of covers a lot of the serving surface. It is a 101. I've seen a lot of familiar names on the Hangout, so it might be some review for you, but hopefully you'll take away something if you don't know much about serving today. My name is Dan Gerdesmeier. I am a software engineer at Google working on Knative. And I don't have a demo like Carlos, so maybe next time I'll prepare something. Most of what I have is just slides. So I wanted to start a little bit talking about problem statement. And problem statement it kind of covers a lot of Knative, but a lot of this is focused on serving here. But really today you have a lot of complexity in developing an application, going from developing to delivering that application to an end user. You got to select infrastructure as service, you got to set up an OS, you got to figure out how to containerize it, figure out how you're going to do networking or any networking overlays that you want to do, making sure that's secure, orchestrate containers, make sure you have good utilization, monitor them, and then collect, aggregate logs and make them easy to display. And you have to control deployment of, how are you rolling out your application when you're updating your software, and how are you splitting that traffic across requests. And what this ends up being is you end up having to learn a lot of tools here. Whichever solution you choose in any of these green boxes, you're going to have to learn, what customizations are possible in the OS, what container runtime are you going to choose, what networking overlay are you going to choose, and what are the options available to customize it, and so on and so forth. And really, what Knative hopes to do is to streamline this a little bit. And so really, as a developer, you're focused on writing your application. You can build either with Knative, or you can bring your own build infrastructure. And then you can deploy a Knative service. And that Knative service handles the monitoring and logging and everything else for you. And the goal here is not to choose everything for you like this previous slide had, but the goal is really to provide a set of pluggable options behind a common abstraction. So as a developer, I'm not dealing with an abstraction of Istio and Kubernetes and Prometheus and everything else that goes along. I'm just dealing with a single abstraction for my application, and the rest of the details are hidden behind. So to do this, Knative started with a set of design goals, and the design goals are listed here. Kubernetes is a very popular platform nowadays for running applications, and from that standpoint, most developers are familiar with it or are starting to become familiar with it. So as far as choosing a base, the declarative API has some really nice properties, and so to meet developers where they are, Knative and Knative Serving has sort of this declarative API. We have the second thing is loosely coupled at the top and pluggable at the bottom. You just saw Carlos present on eventing, and you saw that eventing can talk to serving, but you don't necessarily need to use both. You can build using Knative build, or you can just use Knative Serving, and so you have these three projects that are loosely coupled. If you use all of them, like the experience is integrated, but you don't have to use all of them. And pluggable at the bottom is what I was kind of just talking about earlier. We provide these solutions like Prometheus, like FluentD, like Docker underneath the abstraction of Knative, but you can plug in different implementations to those interfaces so that you as an application developer are only dealing with a single interface. Same API to handle both applications and functions. Like we've seen, the functions as a service offerings and the platforms as a service offerings somewhat diverge as a user experience. And so you have to really decide at the beginning, am I going to develop this as an application, or am I going to develop this as a function? And it's an entire paradigm shift. And, we really didn't think that you should have to make that decision up front, and that there's nothing really inherent to the API service that should make you choose between an application or a function. Simple enough to get started, and scales to handle complex use cases. I'll get into this in a little bit, but I think this is probably one of the hardest goals that we have to balance, which is make something that is simple but usable, but then also make it so people don't hit the ceiling and find the tool useless. Clear separation of concerns. We want to make sure that people can really concern themselves with the. I'll come back to this one a little later. Declarative grows with users' needs. I think that this kind of goes back to familiar with Kubernetes. We have a growing ecosystem around Kubernetes. And I think the declarative syntax is really great from a CI and CD tooling perspective, as well as from a GitOps perspective. So it really helps people develop into a production practice. And then reuse where possible. We're not looking to reinvent the wheel. We're really looking to provide a common API. And so if there are ways where we can avoid having to re-implement and that's honestly better. So the Knative serving challenge, this is sort of what I was talking about with it's simple enough to get started, but scaled to handle complex use cases. We're looking to provide source deployment, container deployment, and function deployment, where functions wrapped up in a container, as well as being able to offer a diverse set of rollout strategies to meet whatever business needs you have. So maybe you're at the point where you're testing it out and you always want to have the latest version running. Maybe you're trying to release slowly over multiple days. Maybe you're trying to have separate staging endpoints, so you're running canaries or integration tests against a separate endpoint, or even multiple endpoints. Maybe you're running a long-term experiment over multiple days and you want to see metrics from both experiments. Or maybe you're trying to do a coordinated rollout of multiple microservices. You have a schema change in a microservice in the back end, and you want to be able to update this in a safe way. And so we want to support all these rollout strategies in the fullness of time, while still keeping the API service very simple to get started and not having to do a whole lot. So that's sort of the problem they're trying to solve, and that's how we're trying to solve it. The next thing is really taking a look at where we are today. And so kind of going to dive first into the components, which is going to be the things that run in your Kubernetes cluster to run Knative serving. And then we'll go into the resource types, which are the resources that you interact with to use Knative serving. And then we'll talk about the dependencies that we have on other pieces of software. So first, serving components, we have 5 of them that we install into your cluster. I have them color-coded here. The top 2 are yellow and the bottom 3 are green for a reason, which is that the controller and the webhook are things that are in the API path. And so when you are making an API call, this is where all that logic lives, and the bottom 3 are really in the request path. And so if you want to think about it as a control plane is yellow and the data plane is green, that would be a fair model. And so the autoscaler and the activator and the queue all sit in the request path to offer the Knative functionality. So taking a look at the API request path, again, the boxes for the webhook and the controllers are colored yellow here. The remaining gray boxes are things that are already provided by Kubernetes today. So when you're talking to Knative serving, you're talking through the Kubernetes API server. So your request comes in to the Kubernetes API server, gets hit by the handler, does the authentication authorization to your service account that you have in your cluster, and then it gets passed. Kubernetes passes this off to the webhook that we have registered, which is a mutating webhook. So this allows us to set defaults and do validation. And then it gets passed to a schema validation to make sure that everything looks good after we set the defaults. It goes to any validating and mission webhooks that you have on your cluster. We don't add any for Knative today, but if you have anything custom set on your cluster, it would get passed to that before it gets stored in etcd. Kubernetes has a shared informer model. There's a bunch of blog posts about the shared informer model that you can read from, but the short story of it is the shared informer watches for changes on the etcd database, and from it populates a queue of work, so things that have changed. And our controllers look at everything that's changed for objects that it cares about, and it looks to see essentially where am I at today for these objects and where do I need to go? And that controller is constantly trying to move that object to match the state of the world. Looking at the data plane side for request to Knative, one thing we offer today, which is a scale to 0 functionality, which I think is fairly unique to our offering on top of Kubernetes. So to do this, we leverage Istio, and we have this concept of the Knative ingress gateway. So your request comes into the ingress gateway, which is just an easy way to think about it is a load balancer. And that is going to route the request to one of 2 places. This place the changes depending on if your container is running or if it's scaled to 0. If it's scaled to 0, it will go through this bottom path here, and it will go down the arrow to the activator. And the activator will look at the information on the request and try to figure out what container needs to be launched and where should I send this. And so it will go ahead and launch that pod, which is the circle surrounding the queue proxy in the user container, and then forward the request accordingly to be handled. If the container is already scaled up, the ingress gateway will instead route it to one of the scaled up pods, and it will go directly to the queue proxy and to the user container. The queue proxy has a few purposes, but one of the main purposes is to write metrics to the autoscaler, and so that the autoscaler can keep the appropriate number of pods around. So that's really it for the components. We are constantly iterating, and so we expect them to change slightly over time. If you have any detailed questions about them, you can hop on Slack and hop into a channel. #API is great if you have questions about the control plane, and #networking is great if you have questions about the data plane stack. I'm sure some people would be happy to answer more details. So the next thing to look at is what are users actually interacting with, or what are developers actually interacting with when they're doing Knative serving, and they're interacting with these 4 resources. We have a service, a route, configuration, and a revision. And there's a diagram up in the top corner here that shows the relationship to them. These are created as custom resource definitions in Kubernetes, which is an extension port that Kubernetes offers to allow us to create new objects within its API space. So service essentially is the highest level object here, and it's this sort of represents the starting point of the tree. And so if you create a service, the service will create a configuration object and a route object. The configuration object you can think of as a sort of a head over time, and so as the configuration object changes, it will stamp out new immutable revision objects. And what this gives you is that you can roll back to previous points in time, and you can serve multiple revisions at once. So you don't have to roll over 100%. You can easily roll back to a previous revision, and you can target multiple revisions at once, which represent different states of time. And we can look a little closer into what these resources look like. So revision, like I mentioned, is an immutable object, and more specifically, the spec or the input that you give is immutable. It runs your container image, creates a Kubernetes deployment based on the input. It does all the auto scaling I was talking about on the previous slide, and injects containers to do networking, logging, and monitoring. And again, these containers are pluggable based on your install of Knative, so you can configure it as appropriate. And it really lives in 3 states, which is active, reserved, and retired. And so these states allow it to essentially, you're either serving traffic, or you're routable, but you're scaled to 0, or you've gotten rid of the revision. On the right, you can see what this object looks like in YAML. And so it's a type revision. Revisions are generated only by configuration. You cannot create revisions. And so the name here is system generated. And then the configuration stamps out this spec. And you'll see on the next slide, when I talk a little bit more about configuration, that this spec is going to match that of the configuration, but will represent a point in time snapshot. So a configuration is unlike the revision, is a mutable object. It encapsulates all your information. I don't have build here for the sake of space, but it encapsulates your build information and all your container information. So in this spec, you provide a revision template, and that revision template is what's going to get stamped out in your revision. So you can give it all the container that you want to run, any secrets or config maps that you need, container concurrency, which is how many requests this container can process at once, how long it's worth to time out on a request, and any service account that you need. Quick question in chat. Let's see if I can pull it up. Is there a means to manage a retention policy for a revision? Yes, there is. And so Over time, this configuration is going to stamp out different revisions. There is a config map that we provide for Knative that you can configure at the cluster level that allows you to say, how many revisions you want to round, after how many days of being unreferenced should they be kept around for, and I think one more setting. So it gives you some granular control over how long you want to keep revisions. The goal is to keep enough revisions that you can safely roll back, but to not kind of make your etcd database bloat. Next concept is route. So route essentially is a set of pointers to different revisions, as well as how much you want to route. So going through the object here on the right, the type is route. You give it a name. If it's created by a service, the name is provided for you. And you can either provide the configuration name, which will track the latest created revision, or you can provide a revision name, which will target a specific revision. You can give it a name, the name allows it to be accessed independently as a subdomain or a subroute. And then the percent is when you hit the base domain, how much traffic is going to go to each. So, if I were to hit this route at its domain name, I would see 50% of traffic going to whatever my latest created revision name is, as well as 50% of my traffic going to a specific named revision. So kind of putting this all together, how this boils up to a service is really trying to provide an abstraction that makes it easier for users to create routes, configuration, and revisions. This is our service as it looks like today in V1 Alpha 1. We are constantly iterating here to try to strike the right balance of keeping it simple while also providing enough functionality. So it might evolve here and some future releases. But taking a look at it is today, Knative service, we have a service object, which today you provide run latest. And if you provide run latest, this will create a route for you, which takes the configuration name, which is from the service name, and just routes all the traffic to whatever the latest created revision is. And then like configuration, you provide that revision template. The revision template is used to stamp out a configuration. And that configuration then stamps out a revision. What happens is, how this gets processed is we have the controller. And when the controller sees that the service has changed, it will go ahead and stamp out the route, configuration, and revision. And then once the revision has been stamped out, that will then notify the controller that it should update the status of the configuration, status of the service, and this all from the sub objects. So to go back and forth, because I don't think I'm doing a good job explaining it right now, essentially you have a propagation down for changes that you make in the spec. So I'd make a change in the spec at the service that propagates down to my child resources. Once that child resource has reconciled or been updated, the status of that child resource propagates back up to the parent. And so by just looking at the service object, you can get information about what the child objects are doing. Today we have 3 modes of running service. That last example showed run latest, which is just run all your traffic against whatever the latest created configuration is. And so that will just get stamped out. It's pretty straightforward. The second mode we have is release, and this allows you to update your application over time without going just straight to the next, as well as that allows you to pick a specific revision that you want to target. And so here you give it a list of 1 or 2 revisions, as well as a rollout percent. And this rollout percent is how much traffic do I want to give to the second revision in this list. And so you can essentially start with the first revision, and then over time you can add the second one and slowly roll out the percent traffic to allow you to do a multi-day rollout or a multi-hour rollout or whatever your cadence is. Release mode also provides some nice handy functionality where you have these subroutes that are created for you, and so you can access whatever revision is in the first index with subdomain of current, You can access the one in the second position with a subdomain of candidate, and you can access whatever the latest created revision is with latest. And so it kind of provides a nice, I say stepping stone here, but I imagine that a lot of people will kind of fall into this bucket. But it's a balance between giving you the full functionality of route and configuration, and you just always running the latest, like the run latest service mode does. The last service mode is it's called manual mode, and essentially is for when you want something with more than a two-way traffic split, or you want some custom sub-route names. And this essentially disables the service from doing any sort of reconciliation. So then you're free to manipulate the configuration and route objects directly. And so I see some new questions in chat. So I'm gonna pause here for a second, answer those. Is there a way to order revisions chronologically? So revisions are stamped out and they're given a generation name. And so these generation names, or these generation fields, are numerically increasing. They, because of race conditions and optimistic concurrency, they might not be chronological if you're sending it from multiple clients, but in general, as the generation goes up, that will be considered a newer revision. And that is what when we say run latest, it is going to be the latest generation that was created. And how can we manage multi DC service declaration? I am not sure what you mean by DC, if you mean multiple clusters, or if you mean, I assume that's what you mean, multiple data centers and then multiple clusters, or if you mean having a cluster spanning across multiple data centers. I think that we don't have a lot of experience today doing multi-cluster deployments. So I don't have any good advice on that today on how to manage it, but it is something that we're keeping in mind and developing. As far as having a cluster span multiple data centers, I don't think you'll necessarily have any problems just using doing whatever you do today. And so here's an example of some route flexibility that you might want to do for manual modes. So let's say I have a domain example.com that is my route, and that route I want to point to 4 different revisions. I want to point 2% of traffic to whatever the latest is created to kind of get an idea if that latest one is good. I want to point then 49% of traffic to revision 7, 49% of traffic to revision 6. And I want revision 5 to still be accessible, but not on the base domain. And so I can access it at old.example.com, but if someone hits just example.com, traffic won't be served. And so this is something that you could set up through route, but it doesn't necessarily exist with the functionality of run latest or release mode today. And so for that, you can use the manual mode to then directly access the route object and set this up yourself. Last, just a quick word on dependencies. So we really sit on top of Kubernetes, and so it's a hard dependency for us. And today I would say Istio is largely a hard dependency. We need it it provides the ingress gateway in the mesh. We do need an ingress gateway for Knative serving. We do have some other options that are in progress from other vendors, so you can swap out Istio if you prefer to use something else. We have some sort of soft dependencies on some monitoring stacks that aren't listed here, but again, those are pluggable at the bottom, so you could choose to not run them, or you could choose to run a different monitoring stack. And that's all I had for today. I'm happy to answer any questions that you have, and if you don't want to ask them here, just hop onto Slack. Hashtag general or API or networking are all good places to ask questions.
I have a question. Between build, so in your initial, one of the very early slides, there was an image show developer write code, go to Knative build and go to serve.
Yeah.
What does build do in this scenario?
Yeah, so today we have essentially on the configuration object, it's not pictured here, but under the spec, and you can view the full spec on Knative serving repo under docs spec.md. But there is essentially, and there's some examples as well in the Knative documentation, but you can provide build input here underneath the spec. And so you can use Knative build so that every time you produce a build, we'll create a new revision from that build. And then you can use the service functionalities to control how you want to roll out that new revision.
Oh, I see. So is it recommended to go that way, or it's optional?
It's optional, so you can either bring it as a container image today, and you can just put the container image that's already pre-built, or you can use the build functionality, or you can use an existing CI/CD system that you already have set up. And so kind of going back a little bit to the design goals is really, we're trying to be loosely coupled at the top. And so, you can use Knative build with Knative serving to get that experience, or you can bring something else. All right, well, thank you. That's all I have.
Cool. Yeah. So for next talk, since we are doing a monthly cadence, as soon as I line up the speakers for next talk, I will update the Knative calendar for next two topics. So stay tuned, and thank you all for joining.
Thanks, everyone.